So today I want to discuss why we need complex number. So let's start with a quadratic equation. Y equals to ax square plus bx plus c, and suppose our a, b and c are real numbers, where a, b, c are real numbers. We all know the roots of this equation, ax square plus bx plus c. The roots of x square plus bx plus c are x equals to minus b plus minus square root of 4ac by 12, and the root is real or not is depend on its discriminant b square minus 4ac. If b square minus 4ac greater than 0, then this part is real and x has two distinct real roots. And if b square minus 4ac equals to 0, then x equals to minus b by 2a. So in this case x has exactly one real root. Then x has exactly one real root. But my question is, what happened when b square minus 4ac is less than 0? Let's see this. If b square minus 4ac less than 0, then x is not a real number. Why? Because in this case, if we square the value of b square minus 4ac square, then this is equals to b square minus 4ac, and this is negative. And we know that there does not exist any real number which square is negative. So in this case, when b square minus 4ac less than 0, our root does not lie in real line. This is not a real number, and we see all these things in graphically. So basically this is the equation of parabola. If we write the standard equation of parabola in this form, it looks like y minus k equals to a into x minus a square, where h comma k our part x. Okay, so if we rearrange this, y equals to x square plus bx plus c in the standard form of parabola, so it looks like y equals to a into x square plus b by ax plus c, and now a into x square plus 2 into 1 by 2 dx, add b square by 4a square, and then subtract this b square by 4a square minus b square by 4a square plus c. If we rearrange this equation, it looks like of the form y plus b square minus 4ac by 4a equals to a into x plus b by 2a whole square. So our equation y equals to ax square plus bx plus c looks like y plus b square minus 4ac by 2a by 4a equals to a into x plus b by 2a whole square. Now if b square minus 4ac greater than 0, then if b square minus 4ac greater than 0, then our x is real number, and this equation ax square plus bx plus c has two distinct values. Then the parabola cut the real line exactly 2 points. So this is looks like either suppose this type or this type. This is the depend on the sign of a. If a greater than 0, then this is look like this type. If a greater than 0 and if a less than 0, then this is look like this type. And as it has when b square minus 4ac greater than 0, the solution has exactly two real roots. Then when y equals to 0, and x equals to minus b plus minus root over b square minus 4ac by 2a. So this cut the real line at 2 points. Now when b square minus 4ac equals to 0, then x has exactly 1 value. So this cut our real line, that's exactly 1 point. This touch or this exactly one. Either this is this type or this type. This is the depend on the sign of a. If a greater than 0, then this type. If a less than 0, then this type. Now, if b square minus 4ac less than 0, if b square minus 4ac less than 0, then there is no real root. So in this case, the parabola does not cut the real line. So either this is look like this type or this type. Now for in this case, how we define the solution of the quadratic equation ax square plus bx plus c? So let's see that. We know that our solution is x equals to minus b plus minus b square minus 4ac by 2a, and if b square minus 4ac less than 0, then we rewrite x equals to minus b plus minus b square minus 4ac into minus 1 by 2a. So now our b square minus 4ac is positive. So this looks like minus b by 2a plus minus square root of b square minus 4ac by 2a into square root of minus 1. So suppose this number square root of minus 1 exists. So now in this case our solution is look like minus b by 2a plus minus square root of b square minus 4ac by 2a into square root of minus 1. And now this is real number and b square minus 4ac is now positive. So all this, so minus b by 2a and root over square root of b square minus 4ac by 2a is our real number. So now our solution is looks like x equals to either alpha plus beta and alpha minus beta I, where I equals to square root of minus 1 and alpha comma beta are real number. then we get a new type of number. This number is called complex number. So, and we denote this as C. So this is look like this type, alpha plus beta I, where alpha and beta are real number and I equals to square root of minus 1. This is called complex number. If you want to see in plane, in 2D plane, this will look like some this type, some alpha plus beta I, x is equals to alpha plus beta I, where alpha and beta are real number. Then alpha is called, this is called real part, and beta is called imaginary part. Alpha is called real part and beta is called imaginary part. If we plot this in 2D plane, so this is like, suppose this distance is alpha and this distance is beta, then this point, so this point is the value of alpha plus beta. So this is our complex plane. So this is the motivation behind complex number. Thank you.